Okay, I'm going to warn you now. This one is going to freak you out at first, and then it's going to click. So you've got to be patient. You've got to be paying attention, thinking about it, and then it's going to click, and you're going to get it. Okay? And you are going to. You've just got to have faith. All right, so first we had this warm-up, and we looked at this expression below to find the value for c, so that I could factor this expression into x plus something squared. So I'm looking at a perfect square trinomial is my goal here. Okay, so I've got to figure out, well, what can go into c? Well, let's remember what a perfect square trinomial is. That means if I've got this a plus b squared, then this is being written as a squared plus 2ab plus b squared. So now I can just think about, well, a squared, well, that's x squared, right? That means a is what? A is just x. And this 2ab, well, I still don't know what my b is going to be yet, but I can say, well, that must be 2 times b times x. Well, but I've got 12x, right? So what does b have to be? B has to be 6. Okay, so let's go ahead and replace that. That means that's 2 times 6, x. There's my 2ab. So b is 6. And so I can rewrite that as my, there we go, there's my binomial squared that's going to lead into this. So now if I just think about, well, x plus 6 squared is going to lead me to x squared plus 2ab plus b squared. What's b squared? 36. So the c that we were looking for here was 36. C equals 36. And now I want to reverse engineer a little bit. I'm going to get rid of some of this stuff, and I want to think about how can I get from that 12x to that c of 36. What's going on here? Well, what I had to do with 12 was I had to divide it by 2 to get to that 6, right, because it's being multiplied by 2. And then I had to square it to get to my c. This right here is the magic of today's lesson. Well, maybe not the magic, but it's a key. And what I'm going to say here is that whatever this is, that 2ab, that b, we're going to look at taking half of that, half of b, and squaring it. And that's going to give us our c. Okay? And you'll see some examples, and that's going to start to make sense. All right? But again, this was just the warm-up, so don't freak out. Let's go ahead and go on to today's official lesson. We're going to learn to solve quadratic equations by completing the square. So the vocabulary, completing the square. To complete the square, a constant c, where we just added that 36, is added to the expression if all we have is x squared plus bx to form a perfect square trinomial. And why on earth do we care about having a perfect square trinomial? Well, let's look at an example. If I have x squared plus 8x equals, let's say, 33, I can't solve this. Well, I guess I could subtract 33 and make it equal to 0, but I'm going to tell you that's going to be ugly. It's not going to work. So instead, if I can turn this into a perfect square trinomial, and remember, I can add anything I want to this side as long as I add it over here, right? Well, so what am I going to say? Remember, I said half of this squared. Well, half of 8 is going to be 4. 4 squared is going to be 16. So let's see what happens if I add 16 to both sides. Well, now I have a perfect square trinomial here, and I can factor that into my binomial squared, x plus 4 squared, equals 33 plus 16 is 49. Hey, look, now I can do what we learned just the other day. I can take the root, and I can solve this. I'll end up with x plus 4 equals plus or minus 7, and then I'll end up with x equals 11 or x equals negative 3. So now I have a way to solve this by completing the square. Okay, so, and I forgot to tell you, I actually didn't want you to write anything of that down. So why do we want to create a perfect square trinomial? Well, because we can then factor and solve by taking the square root. Okay, it's a step that we do. to get to a point where we can solve by taking the square root. And it's going to work for any quadratic equation, any quadratic function that you are solving. All right, so let's back up a little bit. Let's just look at the notes that we got from the warm-up. To complete the square for the expression x squared plus bx, the c that we're adding, we're going to add the square of half the coefficient of the term bx. So if we have x squared plus bx plus, this is our c, b over 2 squared. So what did we have in the warm-up? We had x squared plus 8x, and then we added 16. And then that's going to be equal to, we can then factor that into our binomial squared. That's the same thing as x plus 4 squared. Okay, so now we're going to find the value of c. So we're going to complete this, practice completing this square. We're going to find the value of c that makes the expression x squared minus 5x plus c a perfect square trinomial. And then we're going to write that as the square of the binomial. So step 1, we need to find the value of c. For the expression to be a perfect square trinomial, c needs to be, what we just said, the square of half the coefficient of the term bx. So half, the square of half of b. Well, what's b? b is negative 5. So c has to equal half of negative 5 squared. Well, if we square that, we'll end up with 25 over 4. So now we're going to write the expression as a perfect square trinomial, and then we're going to write it as a square of binomial. So we're going to substitute what we just got, that 25 over 4, in for c. So we end up with x squared minus 5x plus 25 over 4. And now we can say, all right, this is a perfect square trinomial. We can rewrite that as the square of our trinomial. So that's going to be x minus 5/4 squared. Because now all we had to do was take the root of this again. And we're subtracting because if this is negative, we've got to be subtracting here. All right, so go ahead and pause, try these, and come back when you're ready. Welcome back. I'll work through these for you, but I'm going to do it kind of quickly. So c had to equal 7/2 squared, which is the same as 49 over 4. And I could rewrite that as x plus 7/2 squared. Over here, c had to be negative 6/2 squared, which is the same thing as 9. So I could rewrite that as x minus 3 squared. Okay, so why do we want to do that? Because now we can solve equations like this. So we have m squared plus 6m equals negative 5. We're going to solve it by completing the square. Why? Because that's what we're told to do. And it's actually going to be not that difficult. Okay, so I'm going to rewrite the original equation. So m squared plus 6m equals negative 5. And now I'm going to add something to each side. What am I going to add? I'm going to add my c. So I've got to think about half of that 6 squared. Well, that's going to be 3 squared. So I'm going to add 9 to both sides. So m squared plus 6m plus 9 equals negative 5 plus 9. Because if I add 9 to this side, I have to add 9 to this side. I can't just change stuff over here to make it easier without keeping the scale balanced. All right, now I'm going to rewrite the left side as the square of a binomial and simplify the right side. So all I have to do is factor this down. I'll have m plus 3 squared equals 4. Now I can take the square roots of each side. That means m plus 3 equals plus or minus 2. Need to isolate m, so I'm going to subtract 3 from both sides. So m equals negative 3 plus or minus 2. Remember, write this part before the plus or minus so that you remember, oh yeah, I've got to do 2 different operations. Now I'm going to identify my solutions. I've got to break into my alternate universes. M is negative 3 plus 2, and m is negative 3 minus 2. That means that m equals negative 1 or m equals negative 5. There are my solutions. Okay, let's do another one. We're going to solve 4a squared minus 16a plus 8 equals 0 by completing the square. Rewrite the original equation. And now some of you might be saying, Ms. Decker, hey, this equals 0, and you taught us before that we could factor this and then use the zero product property to figure out our solutions. But I'll tell you what, this is not going to factor nicely. You could factor this, but you're going to be at it for a very long time. So let's go ahead and move this over so that we can solve it by completing the square. So we're actually going to get rid of this plus 8 from this side. So we're going to subtract 8 from each side. 4a squared minus 16a equals negative 8. And now we want to get rid of that coefficient before our variable squared. Before our, we're good. We just want to get rid of our leading coefficient. So we're going to divide each side by 4 in order to do that. So we'll end up with a squared minus 4a equals negative 2. And now we're going to complete the square. We're going to add something to each side. That's going to be our c, which is going to be negative 4, half of negative 4 squared, which is the same thing as negative 2 squared. So basically we're adding 4 to both sides. A squared minus 4a plus 4 equals negative 2 plus 4. And now we're going to write the left side as a square of binomial while we simplify that side. So a minus 2 squared equals 2. We're going to take the square roots of both sides. A minus 2 equals plus or minus root 2. See how ugly this got? Add 2 to both sides so I can isolate a. A equals 2 plus or minus root 2. And identify my solutions. Well, grab out your calculator. What is root 2? That is about 1.41. So I've got 2 different solutions that I have to go. A is about 2 plus 1.41, and A is about 2 minus 1.41. That means that A is about 3.41 or about 0.59. There are my solutions. Okay. Checkpoint. Pause. Try these on your own. If you want to try one at a time, you can. Okay. Are you ready? All right. So first thing I had to do was identify what C is. I could add that to both sides. And then I take the root of each side. And then I add 4 to both sides. And now I just need to identify my 2 solutions. If you didn't do the second one, pause and try it now. I'll warn you, it's not going to be as pretty as this. So you're going to want to have your calculator ready. Okay, ready? All right. First thing I had to do was actually move that 125 over. Okay. And now I want to get rid of that leading coefficient, so I divide everything by 5. And now I can hear some of you. I can hear you through YouTube, and you're yelling at me going, Ms. Decker, this number is negative. There's no solutions. It's not that simple. We're not yet at a point where we are taking the square root, so this isn't going to stop us yet. So let's identify C. Well, what's half of 12 squared? 36. We're going to add 36 to both sides. Look at that. See, our negative goes away. Take the square of both sides. Sorry, take the square root of both sides. Subtract 6 from both sides. And then finish solving for both of our solutions. All right. You're smart. You're capable. I will see you in class. Thanks for watching.